Welcome back, grade 11s. And we've got an example here now that we've got tangents going on. And I see an angle between a tangent and a chord. So already I'm thinking tan chord. Let's just check. Is this a tangent though? Because we can't use tan chord if it's not a tangent. ABT is a tangent. Cool. So we can use tan chord. Just something to check because sometimes you're given a circle and it looks like it's a tangent, but we're not told. And we can't just make that assumption. Okay, so ABT is a tangent, so let's just capture that thinking already because we're just done tan chord, so it makes sense that we're going to look at that. So the angle between the tangent and the chord, that's what this is equal to the angle in the opposite segment. So if we start from B and E and we're going across to the circumference of the circle, it means that that must be equal. Now, we could also have gone from B and E and going across to this side of the world, and that would also be 38, which of course we might have seen from angles in same seg too once we had the first one. Okay, so let's capture that because no doubt we're going to need to find what those angles, and they were so quick and easy to find. We know that that's going to be 38, and that's also going to be 38 from tan chord. So C equals 38 degrees tan chord, and we also know that D equals 38 because of tan chord. Okay, so those we've got and put in the diagram. O is the center. Okay, well if O is the center, we've got angle at center and angles at circumference. So let's just capture what I'm saying there and saying from B and E we can create quite a thick line there of BO. We can create an angle at the center, and we've also got an angle at the circumference starting from B and E. So therefore we know that that angle there is just twice the angle at the circumference. Okay, well let's capture that. Remember, you've seen my style already where maybe we don't need to find these, but man, they're so quick to find. I feel like let's just work out that that is 76, 38 times 2. So that's angle BOE. BOE is 76 degrees because angle at center is 2 times angle at circumference. 2 times angle circumference. Okay, so wait, let's see what the question's asking us. Find the sizes of C, D, and OBE if EBT equals 38. Okay, well, C, that's done. D, that's done. BOE is 76. And looks like we've wasted a bit of time because we don't actually need that angle over there at all. We could now work out these two from isosceles triangle, but we would really be spending unnecessary time because rather what we should spot, you can hopefully spot it as I find the right cookie here, and that is that we've got a tangent and we've got a radius, and we know that the angle between the tangent and the radius is a wonky 90 degrees. So if that's 90, then we know that the angle in between, well, if that's 38, we're left with how much to get to 90? Well, I think it's about 52, but you can always check on your beloved calculator. So that angle there, that's angle OBE. I'd rather write it as angle EBO to be consistent anti-clockwise, equals 52 degrees, and our reason is simply tan rad. Okay, so maybe that's a good little reminder of not going too gung-ho finding all sorts of angles we didn't need to. So we might have found this angle because of angles on a straight line, this angle, and we would have spent a lot of fun, but a lot of time we didn't need to as well. So do read the question before going too far ahead. Okay, well, I'll see you in the next one.